to a presentation of the CANDELA Horizont 2020 presentation. In this video it is demonstrated a data mining tool for application on Earth observation imagery. Particularly we use a Sentinel-2 image surrounding Paris, covering an area at approximately 100 by 100 square kilometers. The data mining is based on active learning. Active learning is using positive, which are marked in green, and negative examples. With a positive, we indicated that we like to detect, to classify the center of Paris, typical architectural building, and we want to differentiate it from suburbs, which are different architecture, also to differentiate from forest or from various types of agriculture. So in here we had two positive examples and four negative examples. We apply the machine learning and we obtain a classification of the inner center of the city. We verify in the query list, so we have only dense urban, so we recognize actually historical monument in Paris, the Sena, and specific architecture. We verify over all the scene and we do not detect any other patch which was classified. So in active learning, only with two positive examples we succeeded to define very precise a class. We can reset and we search in a similar way another land cover class. So this time we try to classify the forest. We give again two positive examples marked in green and a number of negative examples which are marked in red. We separate it from the agriculture, from the city, and we apply the training, generating the model which corresponds to forest. So in a fraction of a second we obtain the list of all image patches which they contain forest. We verify this on the image and we observe again that we have almost 100% detection, so classification in only a few seconds and giving only very few training samples. So very few training samples, this means they can be verified very well and also we can trust the result. We can go in a more detailed classification. At this time we want to enhance the spatial detail in the grid. And this example is focused again on the urban. We give positive examples covering various kind of urban areas and we separate this from forest, from agriculture. We give two negative examples on agriculture, the other two on the forest. So we obtain the new classification of built-up areas, this time covering the center of the city but also residential areas. So we cover all the area. And now we are going to refine the spatial grid in such a way to have a better positioning, and also having a smaller area we can define new semantic in the data. So we change the grid this time from 200 by 200 pixels to 100 by 100 pixels. And we continue the training, this time specifying very precise categories. And we make a demonstration. We want to extract from here the river, La Seine, and we want to separate it again using negative examples from various kind of urban areas. So negative examples in this active learning are very important to separate the interesting class from other classes. We perform the classification and we detected now the patches which contain the river La Seine, and we obtain the classification which is overall marking the river. So This demonstration was a tool based on active learning using positive and negative examples, which is based on very few training. This means that it is very fast. It's generalizing on huge amount of data, as it's an area covering 100 by 100 kilometers. We can obtain tens or hundreds of semantic classes on a training which takes just a very few minutes. It's an extremely effective tool for browsing, querying, and classification and semantic annotation of satellite image data. Thank you for attention.